Thank you guys all for being here. This is the launch of our brand new event series. This particular event is being sponsored by the School of Engineering, the Engineering and Computer Science Alumni Council, and we have a fair amount of our Alumni Council members with us today, which is fantastic. And I am happy to turn it over to Dean Roberts to do some introduction. Before he begins though, as the presentation is going, if you have questions, feel free to put them in the chat. You can also raise your hand, and at the end, we'll do both look at the chat questions and call on you if you want to ask your question verbally. Dean Roberts, take it away.
All right. Well, welcome. It's exciting to have this inaugural event. I'm thrilled about this because we have spent a lot of time in the last 6 years developing an entrepreneurship program. It's important partly because of what's happening in the world. We've seen over the last several decades an emergence of entrepreneurship inside of engineering and computing, where at one time it was solely housed in a business school. Now this is becoming pervasive in technology, as in partnerships, because of all of these great companies that have grown up, that have spawned, focused on technology out of computer science and out of engineering. And so this resurgence was something we noticed several years ago and wanted to develop something inside of engineering that recognized that and to give our students an opportunity to do something different. Now, our aspiration isn't only that students create companies, though we have some great examples of that happening that we're going to share with you today, but that our students have the opportunity to learn about value added, about customers, about taking their design and their ideas and doing something with it more than just the technical side, but the business side of things. And so it's that marriage that's very, very important to us. So I want to welcome you and thank you for coming and recognize those that have been partners in creating our eTrackinitiative. Venkat, thank you so much for your leadership in this area, for Don DeSanctis for his generous contribution and for naming a professorship in this area. David Konis, if he's here today, but all of those who have become mentors and helped us to really set out and develop what has become our program. This is an Ignite Innovation series. It's our goal to bring this innovation spirit of our students and of our faculty and of our partners to you with shared stories of resilience, of working through difficult times, because we know to create something in an entrepreneurial space, it's not easy, and you're going to hear that. We certainly want to thank our sponsors, those that have donated to us, those that continue us with us as partners, but also our Engineering and Computer Science Alumni Council, because they're committed to helping us grow both in entrepreneurship and in everything we do, and they have been such a wonderful addition to what we're doing. And Lisa, thank you for getting that going and starting an alumni council and bringing them to us. Paula and Michelle for putting this together and all the hard work you do behind the scenes, and I'm sure I'm forgetting some people. This is not just for the students who want to start new businesses, but it's for everyone that wants to interject innovation into their organizations. And so for those of you who are from industry and elsewhere, know that there are many of our students now that are gaining this incredible ability to do something more than just technical, but at the same time have great technical capability. All right, so I've blabbered on just a little bit. But without further ado, I'd like to introduce you to our guest speakers. Andrew Billigmeier, Mechanical Engineering 2018 graduate. Connor Schofield, ME 2017 graduate. And invite you to follow their journey from student to co-founders of Agrishield and ultimately to agtech-entrepreneurs. So take it off, Andrew and Connor.
Awesome, thank you. I appreciate it, Mr. Roberts. I'm going to share the screen here 1 second. Here we go. Awesome. Okay, so thank you again. My name is Andrew Billigmeier, mechanical engineering graduate of USD, class of 2018.
And I'm Connor Schofield, mechanical engineering, class of 2017. And we're happy to be here today and share a little bit with you about our journey into becoming Agrishield.
And our talk is named Resilience with a Cherry on Top. Quite fitting. We've come a long way. A lot of progress has been made, but not without some obstacles and hurdles. And so it's part of the story you'll hear today, and we're excited to share it to you. And so without further ado, the story of Agrishield, and actually of our problem, started early on. So I grew up in a small agricultural town called Linden. It's in Northern California. And growing up in a ag town, you're often exposed to and introduced to problems that farmers in the industry face. And one of those problems is cherry cracking. And so I'm going to take you to the next slide here. For those that don't know, cherries are a big industry in California and in the United States. It's about a $1 billion industry, and they are harvested by hand, so they are picked. And in the months of May, June, and July, when they're ready to be harvested, if it happens to rain at all during that time, the cherries, they act like sponges and they soak up this water. And so you can sort of see it here in your bottom right of your screen in the photo. When the cherries are ready to be harvested and it rains during that time, they soak it up and they split. And so the exterior of the cherry splits. And because of the split, they're actually not commercially viable. The farmers aren't able to sell them. And it's a huge problem because of this lost revenue and lost income. And about 15% of cherries every year are cracked. And on certain bad years, like we saw last year, it can be up to 60%. It can be almost your whole yield. And so early on, I was sort of fascinated by this problem for two reasons. Initially, I thought, I couldn't wrap my head around why there hadn't been a solution yet. How come no one's come up with anything that could be useful? And two, the second reason why was because I thought through my engineering skills I was developing in school, I could provide some type of solution, and I wanted to sort of take it head on. And so that's why we came up with our solution. We started at USD, and the solution was to provide a barrier. So it's actually plastic that's laid out on top of the tree. And this plastic it's a barrier. It provides protection for the tree during this time of rain, so that the rain doesn't actually hit the cherry and the cherry can't inevitably soak up and be spoiled. And we've made a lot of progress with this project. And looking back, we're often asked, what steps did we take? What successful steps did we take to get to where we're at? And I think one thing we did really well early on was putting ourselves in a spot to succeed. So really using all the resources available to us. And so when we started out on this journey, junior year, coming up with ideas and drawings on how we can solve this problem, we took our first step, and we took our first chance, really. And I overheard Venkat Professor Shastri talking about starting a new program at USD, and that's the entrepreneurship program, and later becoming the eTrackinitiative. And I sort of took the first initiative to sign up and say we wanted to be a part of this, and we wanted to get our foot in the door and really go after it. And so we were accepted, and we were guinea pig, one of the first 4 teams that were actually in this program. And so through this program, we're able to progress and develop our ideas and actually pitch and bring in industry members to come give us feedback about this ideas. And through this program, we met an individual by the name of Don DeSanctis. He started out as really an engineering mentor, but also a business mentor, developing the business side of our ideas and helping us develop our product in the engineering setting and the business setting. And to this day, Don is not only a mentor, he became almost his family, and later on an investor. He actually gave us the opportunity to take our senior design prototype to the next level. So we had built a quarter scale prototype, and he said, "Hey, I want to see this sort of come to fruition," and asked us to take time during the summer and make this on the real scale, the full scale. And so on our left, Connor and I spent the summer after our senior year, after our senior design class, in building this prototype. And after the 3 months of summer ended, we knew there was still a lot of work that had to be done. It was sort of just starting out, and there was a lot of improvements that really needed to be made. And I had one more semester left back in school with the 4.5 program at USD. and Connor actually got a job. And so we spent weekdays brainstorming the improvements that we wanted to make, sort of gathering materials and what we wanted to improve, and driving up on weeknights. So I'd pick up Connor, or weekend night. So I'd pick up Connor on Friday, and we'd head all the way up to Northern California, which was a 7-hour, 8-hour drive. And we get there and we work all Saturday and maybe even a half day Sunday just to make the improvements to better progress our prototype, because that's what needed to be made. And along with this process, we knew the steps that we had to take, and we were taking all this time to improve our idea. And finally, after our my school concluded, we were handed a choice and whether or not we wanted to continue and develop this idea that we had. And working with Don, we were actually given a proposal. So he saw what we were doing, and he wanted to see us do it full time. And not only full time with the cherry cover, other ideas that we had in the industry. And he wanted to invest not only in a cherry cover, but in ag tech. And part of that is taking on projects and growing. And so we were given this proposal, and we really had an opportunity and a decision to make whether or not we wanted to continue this after school.
Yeah, and so at that point, starting out was a big leap of faith, and early on, the passion for the whole thing was a small part of it. But I think it's important to stress that your passion for anything is something that you can grow and you can really work on. I certainly had my hesitations about jumping ship and making it happen. I had a stable job in San Diego that I had really grown to like a lot more than I thought I initially would. And then in general, I just had doubts about the whole thing. The idea was still very much in its infancy. But I realized that this wasn't an opportunity that really was likely to come along again. And it was really something that I wanted to do. So in September 2018, I took the jump along with Andrew. We moved up to Linden where he grew up, and moved in with his parents for a couple of months. And when we started, we said, all right, we've got 9 months to get ready for this upcoming cherry season. And the first couple of months, we probably treated it a little more like a typical 9-to-5 job than we needed to. When you're running a business, especially in the early days, everything is on you. You're not going to have a marketing department. You're not going to have a sales department. So those hours really need to compound. And especially in the early days, it was really difficult for us to recognize the progress that we were making. We were sitting behind a desk almost all day, every day, working on our designs and figuring out the parts we needed to buy and all of those sorts of things. But around December, we had our plan sent out to the various fabricators that we were working with. We were in contact with all of our vendors. We felt like everything was coming along, and timeline-wise, we felt like we were in a good spot. Well, fast forward to about a month out from needing to have this all ready for the cherry season, and we realized that some of our fabricators weren't quite holding up their end of the deal. And this helped us sort of break the routine of that 9-to-5 mentality, because it forced us to get out of the office, so to speak, or away from the desk, and start, going out to these fabricators saying, hey, what can we do to speed this up? We really need to get this going, as well as just starting to build things ourselves. And at that point, we started really seeing our concepts brought to life, and it sparked a deeper level of passion for the whole thing, because we realized the only people we could truly rely on were ourselves. So we were putting in 15, 16-hour days, 7 days a week most of the time. And this whole time, from about a month out, we're watching the weather forecast. About 3 to 4 days out, we see there's a storm on the horizon. It ends up being the largest storm in recorded history for this area in its time frame. And we're still scrambling. We still have a few more things we need to get ready, but we get it done. So the picture on the left here that you see was probably taken around 9 or 10 p.m. The night before the rain was set to hit. And then we spent the entire night putting out this plastic and covering as much ground as we could. So on the right there, that shot was probably taken around 10 a.m. the following morning, just before the rain started. And so once the rain started, we said, okay, that's it. There's no point continuing to cover more trees because the damage is done to those that haven't been covered. But we took a step back and we looked at what we had covered, what we had accomplished, and we said we thought we were in a good spot. We brought a couple of customers out, and we actually just stood under the plastic as this downpour was happening, and everything was holding up well, and we were pretty happy with what we put together. So we decided we should take a little bit of a breather after a few days of all-nighters and just round-the-clock work.
Yeah, so we really worked for almost about a week straight every day for about 15 hours, and then put in two all-nighters to get this thing ready. And we had a spot in mind in covering, because it was such a big storm that we sort of really focused on trying to cover one spot and bring out a lot of people to show them what we can do. And so we had it all covered, like Connor said. We brought out multiple customers and showed them what we were capable of, what we were sort of looking to do with this project. And putting in all this work, we decided once it was all up and all looked good and all the customers were gone, to finally take a nap, because it was sort of appropriate at the time. And so we had taken a nap and wishful thinking, we thought everything was good. It was all fine. And we wake up from that nap, and I remember the first thing I remember was the winds were just incredible. And we come out and to what we had done, and we see something like what's on the right. So the winds had gone from 20 to 30 miles an hour starting out to up to 60 mile an hour gusts. And everything, see, it was like a culmination of the whole year. We really spent all year around designing, working with fabricators, working ourselves on putting this prototype together, all for what's on your right. And it was a little discouraging. It left us, pretty devastated and pessimistic because of this time we put in and because of the end result on your right. And it sort of reminded me that, being an entrepreneur is like always putting your head on a chopping block. You really put up your ideas and you put your passion on the line for the public to ridicule and to critique. And it's a good thing. But, sometimes you don't really realize the successes that come out of it, because while we were left, so distraught on what the end result was after all these months, there was good come out of it. So, part of the lessons that we want to sort of preach is finding success out of failure. On the right is absolute failure in our eyes, but part of the approach was bringing people out to show what we were capable of. They saw the equipment we were making, and it was absolutely on a professional level, mechanically and commercially. And so we were actually approached with ideas by these farmers that came out and saw what we could do. And so one failure sort of turned into a success. It snowballed. And one of the ideas that we were brought, and the next one we worked on, was called the drip tape winder.
Yeah, so we skipped one. But so after the cherry season, like Andrew said, the customer came to us with an idea for a pretty simple device, and there are some other ones on the market, but they wanted an irrigation hose winder that they could power off of the hydraulics from a tractor. And they wanted to sort of cater it to orchard crops. Most of what is out there is designed for row crops, things like corn. And so we spent the next couple of months after the cherry season designing and then prototyping this irrigation winder. So that's what you see on the left there. And then in September of last year, we had a bit of a setback. So we were out testing this device, and to keep a sort of long and gruesome story, hopefully less of both of those, things went sideways, and I ended up in the hospital with 4 partially severed fingers. And the aftermath of this just really made me kind of have to reassess where I was at, where I wanted to be, and where I wanted to go. It brought me back to that kind of classic interview question that everyone always gets, but no one knows how to answer. And I still don't think I know how to answer it, but it's the question of where do you see yourself in 2 years or 5 years or 10 years? And again, I still don't think I could answer that, but I could say where I don't want to be. And I think where I don't want to be is sitting behind a desk and working for someone else. And I realized that I do have a deep-seated passion for invention, for solving problems, and for building things. And so that helped me sort of get back into the swing of things. After a few weeks, I started getting at least back on the computer, doing some design work while Andrew was at the shop building these. And then a few weeks after that, managed to get back into the shop. And the very first thing we approached when we were both back in the shop was the exact thing that had caused the issue in the first place, was these winders. So the bottom right there you see was 3 of our next version of this device, 3 of the first 5 that we actually built. And to this day, all 5 of those are sold, and we're taking orders for more of them. And I think it was really useful to face that problem head on, and having that sort of discussion with myself, and realizing that my passion for this, not even just this endeavor, but the whole idea of self-direction, was really instrumental in helping get past that. It was huge in overcoming that obstacle. And there's all sorts of obstacles that you'll face as a young entrepreneur and just as a young engineer. But I think that the big thing is that passion and your enthusiasm. Enthusiasm is hugely contagious. And whenever someone sees that enthusiasm, they're going to reciprocate. The other part of that is that it's important to show people what you can do, not just tell them. So perfect example was we brought out those farmers after the cherry project had gone through its test, and showed them what we had done and how we did it. And they really respond to that. You know, it's one thing to say that you can do something. It's a whole other thing to actually do it, and do it in front of someone. And so that's really, like Andrew said, it's snowballed into other things. Now we're at the point where we don't even really have to go out all that much and find projects for ourselves. For the most part, farmers come to us with these ideas, and we get to the point where we can decide what's worth taking up and what's not.
Yeah, and so sort of building off that, the second project that we were sort of given through the cherry project was this great sucker remover on your left. And so this video you'll see it in a grape vineyard, and a lot of the pruning for grapes is done by hand. And so part of the mechanically push to go away from labor and replace a lot of the processes with mechanical work is in developing this product. And so we were given this idea by a customer, and it's something that is pushing us through this next year. So we were able to test it, actually multiple states. So we were all throughout California. We went up to Oregon, and we're really successful in taking orders for this next year. And it sort of just made me realize, 1 year ago from today, we were just getting done with the cherry project, being as it's July. And we didn't have any of these other side projects, and we had an obstacle in front of us, which was a cherry project. And later on, we had to push through another obstacle, which was Connor's injury. But it made us sort of realize that, we, along with the things we've done successfully, was make our own luck. We didn't really let obstacles get in our way. We sort of powered through them. And so we did all the things right, but made a lot of failure, which was important in powering through. And so taking on these projects, is sort of, it's been awesome to see it grow. And you can see another video on the right. We're just involved with a basil harvester. And so it's sort of just, it's awesome to take a step back and sort of look at the progress we made, because just a year ago, who knows what, all the obstacles that we would overcome. And so I know a year from now, there'll be so much more. And I'm pretty excited to where we're growing and sort of where we've gone already. So that's really the end of our talk. And
yeah, we'd love to answer any questions and elaborate on anything that.
Yeah, anything we missed, and we're opening up to questions.
Yeah.
Well, let me kick it off with a question. I'm sure I've seen some coming on in chat, and there are some other ones. But first, thank you for your great story and your story of resilience. By the way, we're really proud of you as USD graduates for the great work that you've done, for the example you've done for other students that will come in the future. Your story is something we can share with them that I think will give other young entrepreneurs hope. Thank you to our partners. Gareth, I know you're there, you're out there. Baron, you're out there. You've been investors in the program, and others have also. So thank you for participating. Maybe just the first question is, so you've shared a story about how you did things. What do you do? And you still don't have a marketing team and all the teams that you might have. You've had to build this yourself. What are you doing for marketing now? How do you market this product?
Before answering,
products.
and Andrew, can you unshare your screen so we can see your faces? That'd be awesome.
Do an unshare there.
Yeah, absolutely.
There we go.
There we are. Yeah, so we sort of really got into marketing with this great machine that we made. And the first thing we did was sort of just develop the local market around us. So it's a lot of just, person-to-person contact, going out and showing them what we can do, like we did on the cherry project. But then we sort of wanted to take it to the next level because, there's grapes all along California. And so hammer social media. We've had a lot of social media presence, flyers, really just networking and trying to meet the right people. And so through social media, we've had enough offers that kept us busy throughout this whole process to test. Like I said, we were in Sacramento, in our area, San Joaquin Valley. We went to Oregon. So our main marketing methods right now have been primarily online and just, flyers, face-to-face contact.
Yeah, and I think an important thing is, I think a big part of marketing is understanding the market itself. At first, we were pretty skeptical about going with the social media route for any of this. I think in our minds, farmers probably aren't the most technologically involved people. But particularly with grapes, there's 1 million acres of grape land in California. And so at a certain point, you can just take a shotgun approach, and some of those are going to hit. So I think a big part of it has been learning to understand the market that we're actually going after, and realizing that all these different methods are going to be potentially helpful.
Yeah. Wonderful. Well, let's open it up to questions from other people there. Michelle, Elisa, are you mitigating this or?
Well, there was another, Regina had a question, which was, what helped you most in your time at USD as a student entrepreneur?
What helped you
most?
Okay, what helped you most in your time at USD as an entrepreneur? I want to say personally, the approach that we took was really to spend a lot of our time in developing our ideas. And a lot of that at the time, you sort of think you have ideas, but they're not the right ideas, especially, not being that experienced. So I would say, to answer your question, what helped you most was really getting a personal connection with a lot of our professors, shop advisor Steve Saxer. We spent countless hours just sitting there presenting probably what was dumb ideas to them, but to us, sort of made sense. And so what helped me most at time at USD was spending time revolved around an idea because I wanted to see it grow. And so I'd say, your spare time filling with trying to grow whatever you're trying to grow, whatever project you're trying to take on, whether it's, starting out in a machine or trying to build something else, involving all your time around it and using the resources there.
Yeah, absolutely. I would agree with that. And just add on that as a student, it's very unlikely that you have much experience designing and building real life things. And so, like Andrew's saying, really bouncing your ideas off of professors who do have that experience with real life scenarios has been hugely important.
Hey, there is a question, Connor. They want to know how your fingers are doing.
So you can see it there. The big damage was to my right hand. Most of my middle finger was lost, and then about, I'd say, a third of my index finger, and then just the two tips on my left hand. honestly, I got pretty lucky. I was pretty quickly taken to kind of the premier hand surgeons in the Bay Area up here, and they recovered what the most that they possibly could, and it's still like definitely constantly on my mind, but like with anything, it becomes normal with time. There's certainly nothing that I find myself like struggling to do day to day. So yeah, I'd consider myself lucky, all things considered.
Well, and great for what you're doing. Is the cherry tree project still going? I mean, you showed a pivot to some other products, and you talked a little bit about the problems and challenge of the cherry tree cover. Is that still something you're working on?
Yeah, it was sort of a little point that I think I might have skipped over, but yeah, the cherry tree is going. It's something that we realized with that test was that just all the scope of the project is so huge. There's so many factors that we didn't anticipate, like these winds and sort of dealing with them. And so we sort of we took an approach where we love what we're doing and we want to continue what we're doing. And so we sort of realized, okay, in order to keep developing this cherry project, we need to make money with other projects first, because we want to be able to continue to grow. And so we sort of wanted to span out the cherry project to be able to successfully drive it to the market. And that was going to take maybe 1-2 more years of testing while we worked on these other projects to bring in income. So yeah, it's absolutely still in the works. We're continuing to develop it. Luckily this year we didn't have much rain to test it for, so it wasn't the biggest of our concerns, and we were able to work on some of the other projects that we showed you here.
Yeah, and just a minor note on that. Part of the tough thing with that project is that the window to test is so short.
Yeah.
So last year, granted it was the historic amounts of rainfall, but it really goes for any year when there is any significant amount of rain. Your window to test that machine is no more than a couple of days.
Yeah.
And that's for an entire year. So
when is that harvest season? I just bought some cherries at the store. Is it right now? Is it coming up? When are we getting that again?
Yeah, so you'll see cherries right now because it's coming from out of state. For California, you're going to see a late April to late June window. So that's the harvest for cherries.
All right, so we're going to wait till next year, April, June, and see you deploy again, right?
Right.
That's correct. Yeah. Yeah. It's hard because you spend all year thinking, okay, this is all I got to improve. And we have some of the ideas that we want to test. And then it comes up, and if those don't work, you sort of almost got to wait another year to build something new in order to test. So it's such a long scope that it's really hard to narrow it down to 1 year.
Yeah. So so Andrew and Connor, did you guys grow up around machinery? What brought you to engineering? Why this versus another subject? What brought you into this area?
So I didn't grow up around machinery. So Andrew's from an agricultural area, and his family has that background. I grew up in Maryland on the East Coast in a very much suburban area.
Crabs.
Exactly, crab cakes and football.
Yeah.
And so to answer the question, no, I didn't really have much experience with machinery. Certainly no fabrication experience. I spent a lot of time on boats, but not like working on them or anything of that nature. I think I think it's cliche, but the sort of what got me into mechanical engineering was I liked math, I liked science. I said, heck with it, I'll go with engineering. And I didn't actually really fully commit to the mechanical side of that until probably maybe halfway through freshman year, or maybe towards the end of freshman year even. For me, it was I realized I really like seeing things in front of me, and the mechanical side of engineering really allows you to be hands-on and to see physical things that you can that maybe you have designed really come to life. And so I think that's sort of what steered me into mechanical engineering.
Well, you're certainly both great exemplars of that. Is your market mostly California, or is this something that could apply to something broader than California?
The cherry project is California is a player in that market. It extends Washington, Oregon, Michigan. So in that project, it's multi-state for sure. Grapes, I think like I'd say 90% of grapes are grown in California. We had the opportunity to go to Oregon, as I mentioned. So there's some out-of-state projects. In general, you'll see a lot of projects that in ag that are really regional because of the climate difference in different areas. So when we went up to Oregon, we had our machine done. We had 2 months of testing, and it works well here. And we went up, and it was a totally different scenario. And we're actually in the process of building a whole nother machine just for them. So our projects are start in California, but through social media and advertising, we've sort of gone now all over the place and really taking on anything.
So it sounds like you're still busy. Both of you are busy, still engaged, and still having a good time. Are there questions from anyone else out there that would like to say something?
Richard Trulick had a thought about the cherry cover. Where's Richard?
I'm reading that here. Look at this. Yeah. So Richard, I'm gonna give you the rundown of where we started. We actually started with the individual cover. So our approach that we started that you saw in the presentation was a universal, like one tarp that covers the whole thing. But we started with almost like an umbrella that would be attached to each tree. We realized really quickly the reason why it didn't work was not because the umbrella wouldn't protect it, it was because mounting, getting in there, actually the economy of scale of putting out an umbrella to every single tree, the math didn't add up to make it profitable, really.
This is Venkat. I have a comment. I just want to say thanks to all of the faculty who helped you guys. Some of them are here on the session today, but you're right. We have a fantastic faculty who just help all the students a lot. And that's what makes me look good.
Hey, Andrew, can you hear me now?
Yeah, absolutely.
Oh, okay. Yeah, I wasn't talking about putting an umbrella by
sorry.
Yeah. Are you okay? Can you hear?
Yeah. Go for it.
Okay. I wasn't talking about putting an umbrella by the trees, but actually designing into your cover. They can be flat, putting some kind of air escape system, which would allow the air to escape and therefore remediate the upward lift on that would probably work. Really expensive, but at least you'd have something that would be effective.
Right.
So, I mean, that's just an idea. And are you guys, I want to ask you another question. Are you guys also interested in other agricultural ideas? For example, I was working on a project a couple of years ago with a company that just didn't have enough funds to go forward for manual pollination. They would have a sprayer system that you could put onto a tractor and drag between rows of trees and spray them with pollen. Okay, and they had designed an electrostatic spraying system, which imparts to the, what they do is they create a pollen slurry, and they integrate it with water, and at the point it is released, an electrostatic charge is imparted to each pollen drop, which then automatically adheres to the stamen of the flower. And what happens is they were getting 30 to 50% increase in pollination. I mean, it was just incredible. I mean, I don't know if you guys might be interested in seeing something on that.
Yeah, and that's sort of how projects start. But I actually just read about that. It's a really interesting problem, and I know there's a whole bunch of chemistry behind it. But yeah, I have heard of artificial pollination. I don't have much background in it, but a really interesting problem.
Well, you know what it is? It's an engineering problem, and quite frankly, they got a lot of people who are interested in doing it. But so much of it depends on what's going on the farm in terms of degree days and stuff like that, and they have to, what happens to the flower. There's a certain level they have to be in, like they have to have between 400 and 800 degree days. If it's too low, you don't get enough flowering, and if it's too high, you may not need it.
Absolutely.
So there's some technology involved in it, and then in agriculture, a lot of it's luck because of weather, which nobody can control.
And
so
I think
you guys are bright enough and have the energy enough maybe to work on something like that. This fellow I was working with, he was really not that well, and he was an older guy, and just he got a great idea. And some of that stuff may still be available. I don't know, but if you're interested, maybe Elisa can show you how to get in touch with me, and I can maybe send you some stuff.
Yeah, I'll follow up for sure.
That'd be great.
Yeah.
And I think that's also a good, it's a good point, particularly with that issue, because there's so much talk recently about the declining bee populations, and those are obviously some of the biggest pollinators that there are. Around here, it's mostly beekeepers that go with boxes of bees, and they rent them out basically. It's a good point, because there's so many projects like that where there's the changing environment and the changing even wages are just driving innovation. The sucker remover that Andrew was talking about is another example of that, where that process is something that most people around here are still doing by hand. But as labor costs go up, it's gonna have to be replaced mechanically.
Well, that particular project is a revenue increasing project. I'm working on another one now, which has to do with pest control, and that's a crop saving problem, and it's does not involve the use of any pesticides or anything like that, and that's into development now. They've just, as a matter of fact, this company was just awarded a grant from the National Science Foundation, and so we're going to be looking for money for them, and that's going to, if that goes through, that's going to be enormous, just enormous.
Absolutely.
The company's called SolarRid, SOLARID, SolarRid. You might look it up at solarid.com.
I've seen that name pop up in a few different publications. Yeah, it's a cool concept.
Thanks, Dick. I will definitely put them in touch with you. Are there any other questions?
There's another question here.
Yes.
Michelle?
Yeah, Art Sanchez had a question. Would macro tunnel be an option or possibility for protecting the cherry trees? They're used to protect raspberries and blueberries.
So, not familiar with that particular term of a macro tunnel. My assumption is it's more like a greenhouse type of setup.
Can I Google that?
Yeah, go ahead and Google that. We're not presenting, but there are maybe a couple companies, mainly in Europe right now, that are working on. Yeah, so it's a greenhouse type of deal. That have systems like that. Our system is, the idea from the start was that it would be a deployable thing. So in California, especially in the region that we're in, the trees are not grown in a very uniform way. But then after the harvest, they come through with what they call toppers, which are basically just giant, hedge cutters almost, and take down the tops of the trees, as well as the sides of the trees, into a more uniform shape. So part of our challenge from the get-go for this area in particular was that they use these really aggressive mechanical processes after the harvest. And if you have some sort of infrastructure in place that can't really be easily taken down, it would be a big hindrance to that. But I think if you were to go up to Washington or Oregon, where they plant their cherries in a different style, they have trellises, which basically wires that guide the plants. They also grow their trees a lot smaller. You'll see some systems like that are getting adopted more regularly.
Yeah, and just to touch on that a little bit, it's a size problem too. Raspberry and blueberries I know are a lot smaller, and it's a little more manageable. So systems can be installed for a little cheaper. Size of cherry trees, at least around here, like 12 or 14 feet. And so you can sort of, we can go back to that first photo, but you can sort of see just how big, compared to a tractor.
Share the screen.
Oh, yeah, you're right. We'll just share it for a second, but the size also somewhat prevents you from installing somewhat of a structure around it too. It's obviously possible, but scaling up, it's always to see. It's always hard to figure out it would cost on a big scale.
So just for perspective, those the two main pieces, and this is our very first prototype, but those pieces going across over the trees are probably sitting at about 16 feet in the air. So like Andrew was saying, the scale of a tree versus like a raspberry or blueberry bush, just it changes that dynamic a bit.
Yeah. But that's
I'm sure you guys have received lots of advice in your lives during all of this, and you've had some pivots and you've had some changes. Maybe you could tell us, for any new students starting these teams, do you have a piece of advice for them? What would you tell them, thinking back to your early days when you started? What's your best advice for students trying to do something that they think is the solution to the most important problem in the world?
I'm gonna preach what maybe Shasbury would tell us back in the day. I think you got to understand your problem, because you could say just go for it and start building, but until you really understand your problem, you might just be wasting time. So I would say, if you had something that you wanted to implement, whether it's an app, a machine, anything, I would say go do market research first. Go talk to people, find out what type of market there is for this. Find out the biggest assumptions that you have and really just tackle them. You say, oh, well, if I build it, these people will come because they need to. Really feel like, find out why that's necessary and do the necessary market research, because that solves half the problem.
Yeah, and going off of that, I mean, if you can, granted, our project was a little bit difficult to do this with, especially during the school year, but really, like Andrew's saying, validate any assumptions that you're making with your customer, as well as with whatever your product is that it interacts with. So with us, it was these cherry trees. So one of the things we had to do was just pretty simply go and take measurements. So yeah, going and just validating your assumptions as best you can before jumping into a heavy design is huge.
Well, I'm sure we'll use you in the future to talk with our students and others who are doing this. I want to thank you for spending some time with us this late afternoon to share your experience. It's a wonderful story, and we're sorry about your fingers.
Thanks.
I don't think they're growing back, but you've given a lot for your cause and for your vocation, your passion, and that's a wonderful thing about both of you, that you've cared so much. So thank you to all of those who are.
I think.
Go ahead.
Elisa,
Maybe I'm cutting this off early. Yep, go ahead.
No. Before we go, I think Elisa or Michelle, we kind of want to just announce that this is a continuing series. So if one of you guys wants to kind of talk about the fact that we're planning another one in the fall, it'll be great.
So yeah, we do have a speaker identified, Mara Aspinall, I think I'm getting her name right, who is a leader in the health technology biotech industry. And we have that tentatively planned for October 29th, midday. So tentatively save that date. We'll be sending out more information on that. But Andrew and Connor, you guys were our first guinea pigs, and you did an incredible job. And we're so proud to have you as alums. So thank you so much.
We're used to big chances. Don't worry about it.
Yeah, thank you, everybody, partners, faculty, staff, all of you who put so much time into making our programs wonderful. Andrew and Connor, thank you so much. You have a great evening, and go back to work and make that cherry tree cover work.
You got it.
Make a million,
guys.
or two or three.
Everyone, thank you. I appreciate it.
All right.
Good job, guys. Great job.
Bye, guys.